All right, guys, so we are on learning objective 20, which is to determine the number of protons, neutrons, and electrons in an atom. So on these guys, you have three different particles, three different subatomic particles. You have the proton, neutron, and electron. So let's start with the proton. So I got the proton. The location of the proton within the atom is in the nucleus. The charge on a proton is positive, so positive 1. The mass of the particle in AMU, so like AMU is 1. And then the mass of the particle in kilograms is 1.67 times 10 to the minus 27 kilograms. Really, really teeny tiny. Which is part of the reason why we use this in AMU here, and we'll talk about that in just a second. So if we change the proton, we change the element. Change the proton, we change the element. Okay. And then we have the neutron. So neutron is also in the nucleus. It has no charge. It is 0 charge. Has no charge. This is also 1 AMU. And it also has very similar mass, 1.67 times 10 to the minus 27 kilograms. Okay. If we change the neutron, we are changing the isotope. Okay, so if we change the neutron, we're changing the isotope. Both of these guys, so the proton and the neutron, are both in the nucleus. And they contribute to mass. The one subatomic particle that we have not talked about is the electron. So the electron is in what we call the electron cloud. In the electron cloud, this guy has a negative charge. So the positive proton negates the negative electron. This guy has a atomic mass unit of 0 AMU. And the reason he has 0 AMU is because his kilogram mass is very, very small when we compare it to the proton or the neutron. So the actual mass for the electron is 9.11 times 10 to the minus 31 kilograms. This is its much, much smaller number than the masses of the proton and the neutron. Now, if we change the electron, so we take out electrons, we add electrons. That's what we say when we say change. We are changing the ion. Okay, so ion. You could also say that we are changing the charge here. The only thing that can change and cause a difference in charge is the electron here. Okay, so now the electron gives rise to the properties of the elements. So the properties of the atom are determined by the electrons and how the electrons are in the electron cloud. So just a few definitions. So this atomic mass unit, what is that? AMU is the atomic mass unit, and it's based on carbon 12. Imagine that. So the isotope carbon 12. And basically what it states is that 12 gram, like if you break up your 12 divided by your 6 protons and your 6 neutrons, you get the atomic mass unit of 1 for a proton and 1 for a neutron. Okay, so it's the atomic mass unit. It's based on carbon-12. That's all you really need to know. Okay, this is the unit that we're going to use the most with when we talk about the periodic table. Okay, so then we have an ion. So an ion is an atom that has a different number of electrons. So lost, which means it's positive, or has gained, which means it's negative electrons, and has a charge. I don't know why that's an and, has a charge. So this guy's going to charge you. Okay? He's an ion. He's going to charge you. He can actually kind of shock you sometimes with the amount of charge he can gain. Electricity is where you kind of equalize the charge between yourself and something else. So, the isotope symbol. This guy consists of a element symbol surrounded by the atomic number, mass number, and charge. Okay, so isotope symbol consists of an element symbol surrounded by the atomic number, the mass number, and the charge on the atom. So let's look at carbon again, because I love carbon. It's such a great element. It makes up everything. So you might not want to, atoms make up everything, so you might not want to actually believe them all. So carbon's element symbol C. If I'm looking at carbon 12, I'm going to have 12 at the top, and then 6 at the bottom, and then a 4 plus at the top. Okay, so then this is what we would call A, and this is the mass number. And this is what we call Z. I have no idea why it's called Z. I just know it's called Z. Okay, I didn't make this up. It's Z, which is the atomic number. And then the +4 in the corner is the C, which is the charge. So C is the charge due to loss or gain of electrons. Again, loss is going to be a positive charge and gain is going to be a negative charge. So in this case, carbon has lost 4 electrons. Okay. A is my mass number, and this is equal to my protons plus my neutrons. Plus my neutrons. And then I have Z, which is my atomic number, which is my number of protons. So then I can go through this guy and state how many protons, neutrons, and electrons I have in this atom. Okay, so if I want to know the number of protons for carbon, so protons is equal to 6, that's always equal to the atomic number, and that number is always going to be on the bottom. My number of electrons is going to equal to my number of protons minus the charge. Okay, so then in this case, I have 6 protons minus 4, and that's going to give me 2 electrons. Okay, and then my number of neutrons is equal to my mass number, so mass number minus my atomic number, which is 6, okay, or the number of protons that I have. So then my mass number is 12 minus 6 is equal to 6 neutrons. So this guy has 6 protons, 2 electrons, and 6 neutrons. Now, I could change this. So let's say I change this to be 4 minus here. Okay. The only thing that's changing here, I'm not changing my protons or my neutrons. The only thing that is changing is my number of electrons. So again, I'm still going to use this same formula, right? So my number of protons is 6 minus negative 4. So I'm going to add these guys together, and that's going to give me 10 electrons there. So like if I had a negative sign, it's going to be minus the negative charge, which means I'm adding the electrons in, okay? That is how you figure out your number of protons, neutrons, and electrons in an atom. So this is learning objective 20, determine the number of protons, neutrons, and electrons in an atom. And this is how you do that.